Okay, last few examples for combinations in lesson 3, and then it's just practice, practice, practice. We're on page 106. First thing I want to take a look at is, keep in mind, it shows you the formula for a combination. It also has this different notation called column notation. So when you see it's a column, N and R, the set number and the set goes first, underneath it is the subset, that's a combination. It's automatically a combination. You'll see some of that possibly in your homework. Now if we compare the formulas, we said that the combination should always produce smaller numbers because the order doesn't matter, right? We don't want to double, triple, quadruple count things that look the same. They're just in a different order, the same objects. And so you see that dividing out of that repetition right here in the formula, that extra r factorial that isn't in the permutation formula. And that's why your numbers are always going to be smaller, because we're dividing those out. All right, so we're going to look at page 106, example 1. This is a bit repetitive. How many subcommittees of 4 students can be formed from a student council consisting of 7 students? We have a subcommittee, and we're not given any order to it. We're not giving any positions to our committee. So that makes it a combination because our order doesn't matter. So 7 choose 4 would be 35 subcommittees. Again, if I would have said, okay, I want 4 students from the 7, but I'm going to put them in an order like I have, the president, the vice president, the secretary, and the treasurer, that becomes a permutation. Okay, so you're going to pause the video, and you're going to, on page 107, you're going to complete numbers 1 to 3. Check your answers. If you need an explanation on any of them, then you can start play, and I'll have those explanations. If you think you get it, you can fast forward. There's one more example that we're going to look at together, and then you've learned everything with higher level counting. Okay, so for the number 1, list all the permutations of 3 symbols chosen from the symbols there, circle, square, diamond, and triangle. We want permutations, and so if I choose 3 of them, I have to consider those to be different. So I have to count them each separate. So that makes permutation, that's the justification of it being a permutation. So I could do that, or I could also put my lines down and think, well, I have 4 to choose from, and then 3, and then 2. Either way, whether you do the formula in the calculator or this way, you get 24 ways. Versus in part B, it says a combination, I'll change colors, combination, so then I want 4, choose 3. I should get a smaller number because now these are the same order, right? I consider it the same and I don't want to double count them. So I'm going to divide out that repetition. So this becomes 4. How is the number of permutations of 3 symbols related to the number of combinations of 3 symbols? Well, it's 6 times. The permutation is 6 times bigger. All right, number 2 is just going to have you plug in these into the boxes, the numbers that go there. So A is just getting the answer. You can get that answer. For, let's see, B, the column notation. So this is N, and this is R. So I would have 7 factorial. And then this is actually making you do the formula. So this would be 3 factorial, and then 7 minus 3 factorial, which is 4 factorial. So that's what they want you to do for C and D as well. Use the formula, much like the one back here, and plug in the correct numbers. If you do that, then if you go back up and do the formula for 1A and 1B, you're going to see that repetition being divided out. So for example, if we're using the formula for P3, I would have 4 factorial over 4 minus 3 factorial. Versus for C3, I would have 4 factorial over 3 factorial, 4 minus 3 factorial. There's that extra that's being divided out. So that's kind of the purpose of numbers 1 and 2, making you plug it into the formula. Don't need to do it, just mainly for your information. Number 3, in how many ways can a set of 6 cards be dealt from just the hearts in a standard deck? So we have 13 hearts and I want 6. They're cards, so I know they're combinations, right? Because the order that I have those cards in my hand, or if I lay them out on a table, it doesn't matter. So I have 13, choose 6. So that's 1,716. How many ways? So just ways. In how many ways can a set of 6 cards be dealt from just the hearts in a standard deck if the 6 cards include no face cards? So there are 3 face cards in the hearts. So I want to take those out. So now I just have 10 to choose from, but I'm still choosing 6. They're still cards, so I know I still have the combination. So I have 210 ways. Okay, now we're going to do one more example together that has the combinations. It could also be used with a permutation. And it's number 6 on page 108 in your workbook. And this is where you can think of this type of problem, if you're trying to identify what type of counting problem is, that we're choosing from 2 different sets. Okay. So before, when I had a deck of cards, I was choosing from the hearts. I was choosing from one set, I was choosing a subset of it. Now I'm thinking these problems, I have 2 different sets that I'm choosing from. So an improv team has spots for 3 women and 2 men, and 14 women and 8 men audition. How many different combinations of people could be chosen for the team? So I have women and men. So I have 2 sets to choose from instead of just 1. I'm going to choose 3 women. But when I choose the 3 women, I'm not going to choose 3 women from men. I have to choose 3 women from the set of women. And when I choose the 2 men, I have to choose it from the men, right? That should make sense. So now whenever I think about what am I going to do, I'm going to separate it. So I'm first going to think about, okay, how many ways can I choose the women? And then how many ways can I choose the men? And then I'm going to word it so I think about, well, I'm choosing women and men. So if I put the and in there, I know I'm going to multiply them. So what you do is you treat it just like you did the cards, but we're just going to do it twice. We're going to choose the women under the combination, and we're going to choose the men under the combination. I know it's a combination, well, 1, because they told me, but also if I just think about, if it just said how many different ways can those people be chosen for the team, I haven't put a position to them. They're just people sitting on the team. So this is where you just have to keep your numbers straight as to what you're choosing from. What's the set, what's the subset number, okay? So sometimes I even write it to the side to give myself this clarity that I have 14 women and I have 8 men, okay? And from the 14 women, I'm going to choose 3 women. So that's going to be 14, choose 3. And then from these 8 men, I'm choosing 2 of them. So it'd be 8, choose 2. I want women and men on this team. So whenever I get those, you're going to multiply them. You can do this all in one line in your calculators. You can go 14, go and grab the NCR 3 times 8, go and grab the NCR 2. and hit enter, and it'll give you the answer in the end. So give it a try. Your answer should be 10192, and these are teams, right? How many different combinations of people should we be choosing for the team? Combinations. So there'll be one that you're going to try on your own, and then you have your homework is in your packet. You're going to practice that, complete the homework. Number 4 is a good one. We've already done number 6, so we're just going to do number 4. Okay, so you can pause the video and do number 4. It's ask some different questions, so it'll challenge you a little bit. Check your answers. If you don't get it, then start play, and I'll give a little explanation of some things, and then you can practice your homework. Okay, so this one, a committee is to be chosen from a set of 11 students, of whom Thomas is one. The committee has a chair and 4 other members. In how many ways then can a committee be selected if Thomas is the chair? So if Thomas is in the chair, like he's the head of it, right? He's the person running it, you take him out of the mix, because there's only one way you can choose him. So really now we're down to, instead of 11 students, we have 10 students. There's our set, and we're choosing 4. Okay? It's a committee that doesn't have order. The order doesn't matter. There's no positions. So it's 10, choose 4. So I'm going to put that number up here. Now, if Thomas is on the committee, but someone else is the chair, so now we want to think about, well, to get the chair, it can't be Thomas. He's not the chair. And so there's going to be 10 other, of those 10 other people, someone there is going to be the chair. So you can think of that one as there's really 10 people to choose from. So that you can either do 10P1, or we could just say 10. And then Thomas is on the committee. So we're not going to consider him as well. Someone else is the chair. We've chosen that person. So now take Thomas out. You take that person that's the chair out. We have 9 people left, and we need to put 4 more people on this committee. So the next part would be 9C3. And that 9C3, I don't have that number. I could get it for us. Let's see. So 9C3 is 84. So you have to have the chair and 3 more people, so there's 840 committees. And then the last one, you're just going to combine those two, A and B. If Thomas is on the committee, and he may or may not be the chair, well, in the first one, in part A, you made him the chair. So if he is the chair, so I'll break it out this way, is the chair, and then is not the chair. So 210 ways that he was the chair, and if he's not the chair, then that was 840. Is the chair or is not the chair means you're going to add them. So that one had a little bit more complexity to it, a little more difficult. Again, it's the reasoning coming out in this course, the reasoning through some of these questions. Right, the key is going to be asking certain questions in your mind as you go through this, and that's what we're going to practice in our next lesson is how do I determine what type of counting strategy I'm going to use in order to solve the problem. Okay? So your homework is in your packet, so it's all combinations whenever you think about this. They might ask you to compare and think about a permutation versus a combination, but the questions should all be centered around it being a combination. Choosing either from one set or maybe choosing from 2 sets.